Think about your weekly routine for a second. For most of us, there's this one thoroughly everyday chore that we do completely on autopilot. We pull up to the pump, grab the nozzle, and just fill our tanks. We watch those numbers kick up, wait for that familiar clunk of the handle, and we drive off. But have you ever stopped to wonder what is actually happening in those few minutes? Like, what's the hidden scientific marvel that we're all blindly participating in? Well, in this explainer, we're going to uncover the absolutely fascinating science behind exactly what we put into our vehicles, and honestly, it might just completely change how you look at your next trip to the pump.
So let's kick things off with a seemingly obvious question. Is petrol actually a liquid? Now, your immediate reaction is probably, yeah, of course it is. I literally watch a liquid pour out of the nozzle right into my car. And hey, you aren't wrong about what you're seeing. But if we want to understand how our vehicles are actually powered, we have to look way past that visible surface. We kind of have to challenge our basic assumptions about the physical state of this fuel when it's doing its most important job.
All right, let's dive into Section 1, the liquid fuel myth.
Okay, let's break down this massive misconception that your car is just out there burning a puddle of liquid to get you down the highway. Think about this. If it's just a pool of liquid, why does it smell so incredibly strong the absolute second you pull into the station? Literally, before a single drop is even spilled, that distinct scent hits you. And another thing, how does a liquid fuel burn rapidly enough inside a high-speed engine to propel a heavy 2-ton machine down the road? These everyday clues, the pour, the smell, the rapid burn, they all point to a really fascinating, completely invisible process that's happening right under our noses.
Moving right along to Section 2, the science of volatility.
To really answer those questions, we need to shift our focus away from that visible liquid and look at the invisible microscience happening at plain old room temperature. The absolutely crucial point here is that petrol is highly volatile. Now, in physics, volatile just describes a substance that evaporates really easily even at normal temperatures. It's not like water, right? Water needs to be heated up to boil and turn into steam. Petrol, on the other hand, fundamentally refuses to just sit quietly as a liquid. The very second it hits normal air, it is enthusiastically turning into vapor. And that is exactly why you smell it instantly. Those are the actual vapors escaping the liquid and hitting your senses.
And here it is, the absolute biggest secret of your car's engine. Vapors ignite, not the liquid. Mind-blowing, right? When fuel gets inside the cylinders of your engine, it's the invisible, rapidly formed petrol vapors that are actually catching fire, not the physical liquid itself. Actually, if you were to somehow try to ignite a perfectly still, completely unvaporized pool of liquid petrol, which, by the way, is nearly impossible because it's so volatile, it wouldn't even be what powers your car. The real magic happens exclusively in the vapor state. So it's essentially this precise 3-step dance. Step 1, that highly volatile liquid evaporates into a vapor. Step 2, the vapor thoroughly mixes with the surrounding air. And step 3, this very specific mixture of vapor and air ignites to generate the actual power that turns your wheels. It's a wonderfully efficient physical and chemical reaction, and it's happening literally thousands of times a minute inside your engine block.
Now, because of that super rapid evaporation, petrol creates a highly combustible mixture. On one hand, this is fantastic news for generating horsepower, right? It allows vehicles to create energy incredibly efficiently. But it's exactly why fuel has to be handled with such extreme care. These vapors can catch fire much more easily than most people even realize. The real danger isn't necessarily the liquid splashing around, it's that invisible cloud of highly combustible vapor hovering right above it.
Let's move to Section 3, vapor versus gas.
Now, I want to take a quick, really satisfying detour to clear up a super common linguistic mix-up. In North America, we're always calling it a gas station, right? But scientifically speaking, there's actually a strict difference between a vapor and a gas. A vapor is the gaseous form of something that is normally a liquid at room temperature, just like petrol. A true gas, on the other hand, naturally exists in a gaseous state under normal conditions. Think oxygen or helium. So when we pump petrol, we're dealing with a liquid that creates a vapor, not a true gas. It's a tiny distinction, sure, but a really fun one if you appreciate precise science.
And finally, Section 4, powering modern civilization.
Let's zoom way out for a second from those microscopic chemical reactions and look at the massive global scale of this daily process. Whether you're fueling a single motorcycle or running a massive commercial fleet,
The use of petrol is driven by incredible human achievement. Behind every single drop of that volatile liquid is the complex chemistry of combustion. It relies on thermodynamics to convert that heat into actual mechanical work. It demands absolutely incredible engineering to safely contain rapid explosions inside an engine thousands of times every minute. And when you put it all together, this combined science is what's literally fueling entire global economies.
It really hits the nail on the head. Science reminds us that even the most ordinary things around us often have extraordinary stories behind them. The very next time you find yourself just standing at the pump, watching those numbers roll by, remember that you aren't just pouring some mundane liquid into a tank. You're initiating a highly calculated, meticulously engineered sequence of volatility, evaporation, and combustion. You are quite literally participating in an everyday marvel of human ingenuity and physics.
So, I've got to ask, were you actually aware that your vehicle runs on invisible petrol vapors mixed with air rather than just burning a puddle of liquid directly? It totally reframes how you think about driving, doesn't it? I really hope this explainer has brought some structured clarity to this awesome everyday marvel. Thanks so much for taking the time to learn with me today. Jump into the comments and let us know. Did this change your perspective on your next trip to the pump?